I think informatics at OU has really been a progression of increased capability over the last few years. And it's been driven largely by the science. As the science collects more data, then the need to manage information becomes greater all the time. One of the benefits is the ability to use informatics to bring different disciplines together. So for example, climate scientists can work with ecologists using informatics in ways that they otherwise wouldn't be able to work together at all. Some universities have focused largely on informatics, and then they focus separately on the science, the domain science. But here at OU, I think we've been quite adroit at actually designing the programs together. So it's not a matter of connecting or gluing together informatics with science, but rather they're growing up together. And I think that sort of organic process is much more powerful in the long run.
Having real programmers involved in the research means that I can imagine what the data look like, and even though I can't put them on the screen myself, I can talk to the people who have that ability. I'm an experimental biologist, and I know how to generate the data, but I don't necessarily know how to manage the data nor visualize it. I can imagine what it looks like, but I can't put it on the screen. Increasingly, researchers who are able to cobble together some code that would help them with their project just no longer going to be feasible. We have seen over the last few years a number of researchers come to us and say, I've got this new problem, and I know how to run the experiment, but I'm not sure what to do with the data. Can you help? And the answer is yes, these guys know how to do it.
We are all the scientists, so we are not well trained in the computer science and information technology. So these OU IT group really help to bring that gap. So the real dream is a side-by-side the teamwork between the information technology software development team and this domain science team. So they can work very quickly to address some very challenging scientific questions.
I think that IT informatics is very important for our center in 3 areas. One is to understand the hardware, software, infrastructure, and then provide ideas about what would be the most sensible investment for the development of software and hardware. And the second part is to help database development to understand better database technology broadly. The third part is programming side, that beyond spatial programming, what are the new programmatic thinking, algorithm development that we can incorporate into spatial problem. How do we transform desktop-based research into web-based research, and that really take advantage of the cyber infrastructure development? It makes so much more sense to incorporate the professionals from the IT informatics and then to work with them to really make the good progress rather than have me struggle along the way trying to figure out what is the different terminology means. And that doesn't make much sense.
One of the key things that informatics does for researchers, including those here at OU, is it allows them to tackle bigger problems, really involving larger data sets in particular, beyond the capabilities in computer science and programming for which they were trained as scientists, as engineers, things like that. So it really empowers them, and it reduces the barrier to entry to actually tackle some of the big intellectual challenges that without informatics support really sometimes are intractable, because as a scientist, as a researcher, you really don't have the capability yourself to do it. I think OU can really move forward in the area of application of informatics capabilities to some of the rich scientific problems that we deal with here at OU that really are part of our DNA. Weather, for example, is an area that we have a lot of work in at OU. Huge petascale data sets, environmental modeling, observations from space, high energy physics, bioinformatics, things like genomic sequencing. A lot of other folks do those kinds of things, but what we're doing is integrating them together. One of the things about informatics is I view it as sort of the glue that pieces together various disciplines: computational science, computer science, environmental science, ecology, those kinds of things. Some of the most challenging problems we have as scientists these days are at the boundary of traditional disciplines. Informatics and computer science are very good at being the glue that brings those disciplines together and helps them to talk with one another and to solve those problems.